Hi, at Aspiring Minds Research Labs, we use machine learning to grade open responses. We use the power of data to grade spoken English, motor skills, or programs. With many active efforts towards teaching coding to kids and adults, automated grading of codes is the need of the hour. This can enable large-scale feedback, credentials for learners, and also help the industry hire programmers in an effective manner. Traditionally, test cases are used to grade programs. These are good to find codes which are completely correct. However, they provide little insight in the quality of the code if it doesn't pass all test cases. It also doesn't identify codes which are mostly correct but have silly errors. We want to grade these codes in a way which classifies them at levels of a rubric, generating better feedback for coders and interviewers. We use supervised learning to solve this problem. We get codes for a given question graded by human experts and build supervised grading models. In our 2014 KDD paper, we propose grammar to derive rich semantic features from codes, which could predict grades as good as humans do. It was a success. However, we had to build a model for each question using supervised learning. This process is expensive and time-intensive. It highly impeded the scalability of the system. Building models for coding questions for a typical course will require 20,000 programs graded by experts. In this work, which we will present at KDD 2016, we train a single question-independent model. For a new unseen question, we simply need to feed a set of ungraded codes, the result of test case suite, and our model automatically predicts the grade. The primary idea is to transform the original question-specific features into a new set of features, which retain their relation with grades irrespective of the question. We train a generic model which takes as input these transformed features to predict a grade. How do we create question-independent features? We exploit the ability to automatically identify a subset of codes that solve the question correctly for an unseen set. This is the set of codes which pass all test cases, the good set. The distance of a code from the good set in the feature space is a question-independent feature. For any question, grade is inversely proportional to the distance of a code from the respective good set. Once we have enough good codes for a new question, we can derive the distance feature and apply the generic model. We need to do some more innovations like deriving multiple features, normalizing features across questions, and so on. Read more about these in our paper. We show that our generic models predict grades as good as question-specific models do in most cases. This work makes grading of codes using machine learning super scalable and practical for the real world. We can now get our machine learning models to work for a new question within 2 to 3 weeks, as compared to 4 to 5 months earlier. The same approach can be used to grade in a number of other domains.